of matrices. So there's a little bit of vocabulary. The exercises on augmented matrices, there's 21 of them, and not until you get to problem number 15 or 16 are you actually doing any work with the matrix. The first 14 or so questions are all vocabulary based on the basis of what we have here. A matrix is nothing more than an arrangement, a rectangular arrangement called an array that's arranged in rows and columns. The size of a matrix is defined by the number of rows that are in that matrix and the number of columns that are in that matrix. So if this was what we saw as a matrix, and this is the way that we represent matrices, we put the whole things inside of one big bracket, this would be, and it would be a matrix that has 2 rows and 3 columns. Therefore, we would refer to it as a 2 by 3 matrix. An augmented matrix is where we're heading. For our mindset, an augmented matrix is an abbreviated version of a system, meaning that this is the augmented matrix for 2x plus 5y equals 7 and minus x plus 3y equals a minus 2. We're going to use augmented matrices, and by the way, in the calculator or in print, you will see a vertical bar written between the 2 parts of the problem in an augmented matrix, but it won't show on your calculator. All matrices look alike on the calculator. It's how we use the matrices. Okay? So if I were trying to solve this system, do I have a little bit of work in front of me? Substitution or elimination?
Substitution.
I can do substitution because can I get x alone pretty easily? Remember, I want a positive 1 on this thing, so I could take this x, I could get rid of the 3y, bring it over here, but then I'd have to multiply or divide everything by a -1 to get the x alone the problem. Elimination would be just as easy. Could I multiply this bottom equation by 2 and force these x's to drop out the next part of the problem? So either one. And that's typically what you're going to see. The first problem on your test will be a problem that you can go either way with. You just have to decide which way you want to go and then do it. Again, caveat, beware, if you don't do it the way we ask you to do it, whether the answer is right or not, you're losing all 8 points for that problem. We don't want to turn you into, I can only do this if I have a calculator. It's the concept that we need to understand, but the manipulation that makes it a little bit easier. So if we see a system, we're going to want to take that system and turn it into an augmented matrix so that the calculator can look at it and do its thing, because it's got lots of built-in things for us. So when we say it's an abbreviation for a system, all it does is pulls out the coefficients on the appropriate terms. Okay? Now, if that's the case, in a 2 by 3 matrix, and the 2 by 3 augmented matrix, the first column generally used to hold the x variables. It's really important to keep your x variables in the same column, your y variables in the same column, your constants in the same column. Doesn't make a difference where they are, but the x and y's are on one part of the matrix, and that's usually on the left-hand side. So the first 2 columns of an augmented matrix would be referred to as the variable matrix. Again, most of these are questions on the exercises. The last column is the constant matrix because it holds the constant values, target values we're getting for. And then a couple of other terms that are used in subsequent sections. A row matrix has only 1 row, and a column matrix has only 1 column. Okay, so the matrix that has the same number of rows as it has columns is called a square matrix. So all this is vocabulary. And this can be printed. These are the note slides that are under the notes for the unit. So if you haven't printed those out yet, you can print them off already. So here we go. And this is going to talk about how we're going to use the calculator. So you should have your calculators out. I don't want you to try to write down everything that I'm telling you to do on your calculator, because I already did it for you. So if you print these, they're already there. If you have extremely rapid handwriting and you can write and visualize and touch the keys at the same time, that's great, but I need to develop muscle memory for us, okay? So here we go. First thing I have to do is I have to reset my calculator. Okay? So several steps. We need to get this into a format that we can enter into the calculator so the calculator can do its work. New keys. Fourth key down, left-hand side. Second, alpha, math, x to the -1. Secondary function, matrix. New place to go. Just like statistics was a new place that we went. Menus are going to look similar, in that we have columns that hold information, things that we can do with the calculator, but this is our go-to place. Has lots of power, but it's kind of finicky sometimes. So second and x to the -1 takes you to the matrix menu. If you've never been there before, then this is the way that your matrix screen looks. 3 columns. The names of the matrices, and I can see 7 different letters up there. There's 3 more below this. But I can't imagine us ever needing to use 10 matrices at one time. We're going to just recycle what we do to a matrix and keep re-editing it like we do with the stats list. When we said, I'm done with that list of information, let's clear out the list and go from scratch again. We're doing the same kind of thing. I can't see us really doing anything more ever than matrix A and matrix B. Second column in, all the operations that we can do on matrices, most of which we are not going to touch. But the third column, editing. Edit, have to go horizontally. By the way, you can scroll left and scroll right on your calculator as well. So when you pull it up and it's in the original screen, if you hit the left arrow, it scrolls you back to the right-hand side of the screen, so it's kind of like a big Ferris wheel or merry-go-round or something like that, okay? Editing, I need to put something into a matrix, or I need to change what's in a matrix, just like lists. I need to put something in, or I need to edit. So matrix A is highlighted right now, so let's go into matrix A. Now the vocabulary starts kicking in. The first thing it's going to ask you is, I need to know what the size of that matrix is. You need to tell me how many rows there are and how many columns there are. Make sure you put it in right, because you'll know if you didn't put it right, your template's going to look wrong. Rows and columns. So we have how many rows? 2. So we type 2 and enter, and look what it did. See how it changed the template? So you have 2 rows now, but now it's waiting for you for the number of columns. How many columns do you have? 3. There's your template. And now what you're going to do is you're going to transfer the important information over here into here. But what's important over here is not the variables, it's the coefficients and the constants. Row 1, column 1. Currently holds a value of 0, and that's where you are right now. So row 1, column 1 is supposed to hold a value of 2. Enter. And it automatically goes horizontally. You can use your arrow keys to make it go vertically if you want, but it's easier to put it in horizontally because you're putting it all in one equation at one time. But your arrow keys can still navigate around if you make a mistake and you can change something. Okay, so second coefficient. Understood to be 1. Every cell has to have a number in it. Sometimes that number could be 0, but we know that if we see Y, that there was at least a coefficient of 1 on that. Third row, or third column, that's the constant value now, which should be 8. And when you enter that, notice how it nicely carriage returns you down to the next line. See how the input is very easy for you to be able to go through? Okay, same thing's going to work on the calculator side of things, okay? So second row, Coefficient on x?
4.
Coefficient on y? -1. Now be careful, because this isn't negative. This is subtraction. This is negative. If you put a subtraction symbol there accidentally, and then you put the 1, the calculator will have a hissy fit. And you can say, screw that, I'm just not going to use this ever again. That's what quit means. Or you can do go to, and it'll take you back to where you made your mistake. So now that should have been a minus, a negative symbol in there, and it accepts that. And now the value of 4 is the constant value. Okay, so first step is getting the information into the calculator. Okay, editing phase of the calculator. Now here's where the calculator becomes finicky. The operation we have to run is in the matrix menu as well. But the way the calculator is programmed, you have to go back to the home screen. Because if you go back to the matrix menu, it thinks, even though you're not in the editing column, it thinks you want to continue editing something. So we're going to have to quit to get back to our home screen. Something we didn't have to do in the stats menu, but we have to do here. Second and mode, quits takes you back to the home screen. Second mode, quits takes you back to the home screen. So all of that was what we did right here. Accessing the matrix menu, getting out of the matrix menu, how to change entries into the matrix menu, and now we're targeting what's going to go on down here. Okay? So you had to you had to exit the matrix menu, and from your home screen now, you want to go right back in to that matrix menu. Second, and that's the -1 again. Now notice the change in the screen. How's your screen different than when it was when you went to the first time? It shows you have something in matrix A. And it may be something, in fact, it's something you want right now, isn't it? So we know what's in matrix A, but when we come back to that 8 hours from now, we may not know what's there, and there's no need for us to leave it intact. We're just going to keep recycling this as we go through all the problems. But now we go into the second row. There is a function that we are going to be looking for that is abbreviated reduced row echelon form. That is the abbreviation for reduced row echelon form. That's what its technical name is. As far as you're concerned, think of it this way. That's the program that's going to solve this matrix, it's going to solve this system for me so that I don't have to do it by hand. It's the built-in program like one variable stats was that did all the analysis stuff on your problem. Okay, so we go to the math column, because that's where all the operations are, and we start scrolling until we find the RREF function, and be careful because there's an REF function, and that don't do what you want it to do. It's reduced row echelon form. You select that command, pulls it into the home screen. Now you have to tell it, that's the command, but you have to tell it where to go get the information it's supposed to operate on. So you have to go back into the matrix menu again, and now finally the name column to call up matrix A. So we use this matrix actually not right to left in terms of the columns, but left to right. Not left to right, but right to left, okay? So we use it backwards from the way it would normally appear. Now, theoretically, we should put a closed grouping symbol there, but if we don't put a closed grouping symbol there, it doesn't make a difference. And we enter. This is the reduced row echelon format for that system that we just solved. And what it means is that when we get to the end of this problem, we're seeing something now that looks like this. 1, 0, 2, 0, 1, 4. That essentially says 1x and no y's is 2. In other words, x is equal to 2. And no x's and 1y is equal to 4. Or in other words, y is equal to 4. It solved the system for us. Why it's called the reduced row echelon form?